I'd like to welcome everyone to tonight's SF CloudOps Meetup. Appreciate everyone that could show up tonight. Tonight we actually usually we have external guests, ones that really, we find that in our learning and our journey here into hybrid cloud, we enjoy hearing their stories. But tonight actually is kind of like a two-part story for us. Here at Lithium, we're doing hybrid cloud, we're doing AWS, we're also doing OpenStack on-premise. But tonight we're gonna focus on AWS, and part of our stack that we had took a challenging journey, and there's a lot of learnings in there, and we feel like there's a good story in there that we'd like to share. The one thing about this talk is, and the things that I like about our SF Cloud Meetups that I try to do is I really want to have something that you can take away, that you can look at and see actually how we did this conversion from the data center to the cloud. And so tonight, if you look in our we did link to Matt's GitHub, the presentation, and also to the code samples, so that you can kind of peruse and see if it can help you as you make that same journey, and also learn from the lessons that we learn. So just one note about, this is Lithium. We love, good engineers, so we're always hiring. So if you are interested in looking for a job where you really want to be challenged, whether it's in cloud or in other aspects of engineering in the social space, we'd love to have you come join us. Well, with that, I just wanted to bring up Matt Bogner. He's from Austin, so he's going to talk about going from the data center to AWS. I already forgot your title.
My job title?
No, your stock title.
Oh,
Apologies.
Data center to the cloud.
Data center to the cloud, whatever.
A complete overhaul. Thank you. Like Joe mentioned, this presentation in its entirety, along with code samples, the link here. Rather than dive into those examples, I'm just going to talk about what they do as we go through them, so that you guys can reference them later. I was trying to just make sure you guys have something to take away from it without necessarily trying to take down a bunch of notes. Yeah, I'm a software engineer here, and love fault-tolerant engineering, anything that has to do with all the manual work so that we never have to intervene when our software is running. This is my son Luke down here. He loves to imitate everything that I do, the good and the bad. And there's the bad. Sometimes it slips. I'm not going to hit you in the face with it, but just sorry. Steve Jobs said that people who know what they're talking about don't use PowerPoint or don't rely on PowerPoint. And that's why this presentation is in Google Slides. So or Keynote. This was a team effort. I'm not trying to proffer that I did all of this on my own. Two teammates that I have in the Austin office, Alan Lippert and Paul Allen, although it's not that Paul Allen, it's this Paul. Interesting fact, Paul Allen is creating another startup called Cloud Choreo. He's doing some orchestration, things like that, primarily with Amazon. Yeah, true infrastructure as code for the cloud. So I think it's cloudchoreo.com. Choreo as in choreography. So before I talk about how we did the move, I want to just very briefly and succinctly tell you what our application actually does. Our application is a Lithium Social Web. We do basically social customer service and some other things. If you complain to a brand on Twitter, like at Microsoft, my Xbox is broken, we ingest that conversation or that tweet, and we route it to support agents at Microsoft so that they can respond to you on the social network, having to call 1-800-HELP or whatever. And so the application takes care of making sure that only one person gets you that data, or that response. So this piece of software was actually an acquisition by Lithium several years ago. And we were originally in Amazon already and using EC2 Classic. There were a lot of special snowflakes, even though it was the public cloud. Everything was still stood up manually and kind of tinkered with over the course of time. And that was bad. Then we got bought, and there was kind of a complex migration into our data center. It was a blessing in disguise because it gave us the opportunity to kind of try again in a safer environment while our application was still really young and dumb. And so we got to figure out a lot of things with the application itself before figuring out how to host it for real. Then we grew really fast, and they said, hey, double your number of online users. Hey, double the number of content you're ingesting. Double the number of responses. We kind of scratch our head thinking, oh, that's awesome. What do we do with it? Where do we put it? And then we needed more flexibility. We were trying to get more real-time analytics of the social data that we were ingesting so that our customers could kind of adapt faster. And also expecting the multiples of growth that I was just describing. So those are all of the things that kind of drove us to where we are now. That's kind of how the app works. This is the application that I'm going to walk you through today that we migrated. So we've got the ingestion service here at the top that's streaming data from Twitter and Facebook. It captures that data, routes it to an ActiveMQ queue that's specific to one of our instances. And then we have many copies of the application, the JVMs. They're all written in the Play framework. They're all Java apps. And they are what take care of actually routing and displaying and allowing customer support agents to do responses. We use redis for caching, mysql for long-term system of record type storage, and elasticsearch for indexing, sorting, filtering, that type of thing. So what we're going to do is we're going to walk through each of this piece by piece by piece. And in order to do that, I'm going to have to use a lot of terminology that you may or may not be familiar with already. This is not a basic talk or a basic overview of VPCs, CloudFormation, or autoscaling groups. This presentation will very much assume that you're already familiar with those things. I'll kind of give you some hints along the way if I start seeing a bunch of puzzled faces. But this notation down here at the bottom for autoscaling groups at X, Y, you'll see that on a few of the slides. It just means a minimum, the minimum that we're setting for the autoscaling group and the maximum. And we don't use any triggering anywhere in our autoscaling groups. So we're just not there yet, so don't worry about that. So what exactly are we tackling? There's a whole slew of things, any of you guys that have done this before, that are kind of prereqs to being able to move into the public cloud. You got to have your VPC set up, the CloudFormation to do the orchestration. You have to choose something for config management, have a place to go put your code, build system, DNS. All that stuff's got to be figured out. That's kind of the cost of doing business in data center or public cloud. And then you get to the stuff below the red line, which is what your manager actually thinks that you're doing. Yeah, this guy over here, he doesn't know what I do. So step one, set up the VPCs. We actually used CloudFormation to create the VPCs themselves. And rather than walk you through exactly how that works, I just wanted to give you guys a landscape of what our environments look like. So we're going to run out of multiple regions. And within, we're going to have a separate VPC per what people would normally call an environment. So the dev environment is its own VPC. The prod environment is its own VPC. And we have a public and a private subnet in each availability zone. Okay, and it's kind of VPC best practice, but the purpose of that is that things in the public subnets can be accessed from the internet. Things in the private subnets you can only access from the offices via VPN or from the public subnet. A quick note on Amazon region selection. This was something that bit us not too long ago. There was an outage in US West 1 here in NorCal, where an entire availability zone disappeared on us for a period of time. And there are certain types of software that do not work well in an Amazon region that only has 2 availability zones. And namely, those are pieces of software that rely on a quorum to operate. and I've illustrated some examples here. If you lose any availability zone in that region, you have a 50-50 shot of losing the region, the availability zone that contains your quorum or the majority of your instances, at which point then your software is pointless and you die. So a big tenet of a lot of what we're trying to do here is be able to sustain the failure of an entire availability zone as well as individual instances themselves. Like you saw on the previous slide, this piece of software is running out of US West 2 and EU West 1, which all have more than 2 availability zones. So we're going to use CloudFormation to do a lot of the orchestration and to create the autoscale groups, the launch configurations, ELBs, things like that. This is kind of a blessing in disguise that if you go and touch things manually after they're created, and then you go back and try and update that CloudFormation stack, things tend to not work that well. And so this kind of keeps people from messing with your environment manually because they have been bitten by it multiple times. The running joke in Austin is that Bogner will come and hunt you down if you touch any of his stuff manually. A suggestion, as you think about your boundaries for your CloudFormation templates, is to make sure that you separate long-lived things like your ELBs, your S3 buckets, your Route 53 DNS entries into a completely separate template so that when you create your instances themselves, you can have them register behind the ELB, and then you never have to touch DNS again. Okay? And then you can completely delete the stack and recreate it if you want. And if those DNS entries are exposed to customers or anything like that, you don't have to go and communicate with anybody external. For config management, once you actually launch an instance, then you have to install some software on it. Previously, I came from a background where Puppet was the thing. The Lithium team wanted to use Chef. I kind of didn't care. In hindsight, I actually like Chef a lot better than Puppet. Just feels more straightforward. Here, write a script and it runs in order is a cool thing. But things just run weird. So we chose Chef. We decided to go that route. And then the next hurdle that we ran into was stand up a Chef master and load all of your recipes into it and go. However, everybody at Lithium at the time was learning Chef and automating Chef with Chef. And we didn't yet have a great set of best practices or automation or tooling around it. And so we had people that were changing the basic behavior of a community cookbook and then force pushing it or force uploading it to the Chef master without uploading or updating the version number. And so even if you were pinned to a specific version of the cookbook, you're screwed either way. So we decided to go with Chef Solo for this particular app stack. And I'll explain a little bit more about how that works in our workflow. And secondary benefit is that we also got to eliminate a single point of failure as we went along because having to maintain multiple Chef masters is kind of a pain. And we didn't use Chef Search. So it was a feature that comes with a Chef master that we didn't use anyway or need. So first code example. Various bits of this on the Chef documentation and all over the web. This is just a really succinct, simple block of code that you can run that will bootstrap the Chef Solo client, set all the config, the config for it and the run lists so that you can just see how it works just at a kind of basic low level without having to Google your way through and spend a couple hours. So, and by the way, feel free to interrupt me at any point if you have any questions. So now we have config management. Now we're going to deploy code onto boxes, but where is that code going to come from? A guilty admission is that the current way that we do deploys in our data center, we're pulling off of an FTP server, and we unpack it, and there's your software. It didn't feel great to me. I like things that have versions and checksumming and things like that. So we opted to have a Yum repo. And managing an internal Yum repo can be a pain. It's just one more thing to make highly available. And so what we opted to do is put that Yum repo on S3. And this open source here it's a single Python script that you launch on an EC2 instance and you run it, make sure it never dies. And as long as you provide it the right parameters, it will maintain a hopefully working Yum repo for you on S3. And then the code example on the bottom is alluded to in the docs for the repo manager. But it kind of gives you an idea of how you might read from that repo, that S3 repo, from another box. So the idea, how it works, is you've built an RPM, you place it in an inbox folder on an S3 bucket, and that Python script that's here at the top open source is monitoring that inbox. And the moment that it sees something there, it pulls it down locally, recompiles the Yum metadata for the repo, and then pushes up all of those artifacts into the actual repo portion of the S3 bucket. Okay. The benefit of that is that your application boxes are now actually talking to S3 and not yet another EC2 instance. And so we get to take advantage of S3's pretty badass uptime. Cool, so now we've got a place to go put our builds. Now we actually need something to create our builds. Before, we were using Bamboo, which we were constantly having problems with. It would deadlock on us, it'd stop picking up jobs, the agents would die. It's expensive. It was just kind of a pain for us generally. So we decided to go with Jenkins to do our builds for us. And a major hurdle with deciding to do something like that is, again, how do you make Jenkins highly available? For Jenkins itself, we decided that it didn't need to necessarily be cross-availability zone resilient, so that if an availability zone went down, we could tolerate Jenkins being gone for an hour or two until they brought it back online. So we used the pattern for using a persistent EBS volume. The first code example is just how you would create a volume and tag it with the appropriate parameters. And then the second is, for example, what you might run on Bootstrap when you start up the Jenkins slave. So you imagine the user data that runs on launch of a new EC2 instance. You would kick off something that resembles the contents of that second script, which would go and find the EBS volume that you've already created based on tags, attach it to the instance, and then mount it at varlib Jenkins, which is where the default Jenkins install goes. We've actually tested it out a couple times due to some maintenance that we had to do in Amazon. It seems to work just fine, at least for now. We'll see. Then we use the EC2 plugin in Jenkins to automatically spin up slaves. We run our builds, and then after a period of inactivity, those slaves will tear themselves down. Our application is kind of big, and it's really expensive to compile it in terms of. So guilty admission is we're taking advantage of the fact that these slaves aren't running all the time, and we're going with a larger instance type so that our builds can complete sometime today instead of 4 weeks from now. And then for the slaves themselves, we're using Packer in order to kind of pre-bake the slave so that we're not running Chef and waiting 20 minutes for everything to converge on the slave when it launches. Years. Sorry, I'll repeat the question. How long did we use Bamboo before we gave up on it and switched to Jenkins? You work at Atlassian, don't you? Okay. We several years as Lithium as a whole, but dynamic stuff. When the Dynamics stuff got bought, I think we kind of threw the whole system off kilter a little bit and asked it to do a little too much. So, yeah. I wish I could give you more details on why, but another question. Was Social Dynamics using Bamboo before the acquisition? No, we were using Jenkins. But actually, interesting fact, when I got hired, nobody at Social Dynamics knew where their Jenkins server was. The builds just show up. Cool, so now we have a build system. We've got a place to go put our bits. Then we have a need for DNS. This was a challenging conversation here. Do we really need DNS? Probably some purists out here that say, don't ever log into your box. We're hiring if you're one of those guys. But I actually really like DNS. It just seems to make life simple. That's why we all actually have names and not serial numbers. So long story short, we kicked around a bunch of options. We eventually converged on just putting private IP addresses and Route 53. And so, yes, the world can get to Route 53, but note you can't download the zone file publicly, and if you can figure out what's going on based on hostname structure, then cool. You still won't be able to get to any of the boxes. So we use Route 53 internally. Interesting note is that that decision, Route 53 has added private DNS capability, but that still wouldn't work for us because it will. The internal Route 53 would still only resolve your request if the resolution was coming from within the VPC. See, and I like to be on my laptop and type in a host name, which is obviously not in the VPC, and have it resolve, and so wouldn't work. The code sample here is how you would take a host name and an IP address and register it with Route 53. It's all just using the Amazon CLIs. It's all there in the Route 53 docs, but it's kind of a cryptic syntax to it, and I'm hoping that'll demystify that for you guys. Cool. So now we've tackled the prereqs, and now we get to actually tackle the things that your boss knows that you're working on. And we're going to start with MySQL. We decided not to go with RDS. Primarily because we have a team of DBAs here that are smart, and we have complex deployments of MySQL, and we use MySQL very heavily. And so they're not the largest MySQL installs ever, but they're not cheeky, cute things either. So we want our MySQL infrastructure to be able to tolerate a single instance failing and an entire availability zone failing. And be able to do that without any manual intervention. So to accomplish that, we're going to use MHA, which was written by Yoshinori at Facebook. And it's open source. And combine that with a thing called MHA Helper, which is kind of a wrapper around MHA to on some of the edges that MHA has. And that was written by Ovais. Wave your hand, Ovais. Yeah. Interesting fact, when Ovais wrote that, he was working for Percona, and then he came to the dark side and started working at Lithium, and was like, hey, y'all using my stuff. And by the way, you're using it wrong. So have him come on board and show us what we were doing wrong. This was by far the most frustrating, challenging thing I have ever attempted to automate. So much so that I'm going to walk you through the most challenging bits of that over the next few slides, so that hopefully you guys will all either say I'm going to use RDS, or you'll take advantage of some of my lessons learned, our lessons learned. When we launch our MySQL stack, our CloudFormation template, it has 2 auto-scaling groups in it. One auto-scaling group is for all of the master-eligible nodes, all of the nodes that are capable of being promoted as the master. And within that group, right now we're running a 3-node cluster. One is going to be the master. One is going to be a read slave that we run reports and stuff like that off of. And the other is going to be dedicated exclusively to backups. Okay? Just note that the automation is set up that if you were to increase the size of that auto-scaling group, the additional nodes would come online as an additional read slave. So what I'm pointing out is that there's only ever one master and there's only ever one backup node. Okay? Then we have a second auto-scaling group, which is for the MHA manager. Okay? And that's just it's basically a singleton box. And so we set min 1, max 1 on the auto-scaling group just to make sure that if Amazon ever takes it away, they give us back another one. So MHA itself, what is it doing? It's actually sitting there staring at your MySQL master and waiting for it to die so that it can promote a new slave in its place based on whichever slave it knows to have the most up-to-date replication. And the docs that are on the MHA website that explain how this works are actually fairly easy to follow for us mere mortals that aren't MySQL experts. And so I'd recommend, if you're curious about it, to give it a read. When we create this stack initially, when we create these two auto-scaling groups, note that the master is going to be in one of 3 availability zones because this auto-scaling group crosses all of the availability zones. MHA manager is going to be in a single availability zone as well. It'd be really bad if we put MHA and the master in the same availability zone right off the bat. Because if you lose that availability zone, you're screwed. Nobody will be able to detect that it's gone, except your customers when they madly call you at 2 o'clock in the morning. So the thing that launches the CloudFormation template is responsible for making the initial selection of the master, like which one's going to be master. And the only factor in that decision is, okay, MHA is here. Let's pick a box that's not in the same availability zone. In order to do a failover, MHA requires a virtual IP. It turns out that if you're interested in tolerating the failure of an availability zone, Amazon doesn't have a solution for you for a floating IP unless you're creative. Existing solutions are to have an elastic network interface. All right? Move that between boxes. That has a private IP address on it in your VPC. Problem is that your ENI is bound to a single availability zone. You can't take that one thing and hop it across the boundaries. Other possibility is to use an elastic IP address. That kind of sucks too because that's a public IP address that you're going to put on your database server. Don't do that. Our SecOps team would kill me. So a workaround. It's really disgusting. I compiled this into an email and I fired it off to our AWS account reps and they said, "Holy hell, I can't believe it works." Use VPC route tables. What we're going to do is we're going to take a single route and put it into our route table that takes an IP address that does not conflict with your VPC addressing boundaries. And so if you remember many slides ago, it was 10.blah is what our IP address ranges are. So we choose something that's outside of that. Nothing in our office, nothing in our data center ever begins with 192.168. And we tell that route table to route anything with that specific IP address to that specific ENI. And that specific ENI is whatever the current master is. And then you take Route 53 and overlay a cutesy DNS entry over the top of that 192 address, and you have something that's kind of like a VIP. When you perform a switch, it's pretty much instantaneous. It takes the application maybe a second and a half or two to notice that all of its connections are dead and to churn through the connection pool and take off a brand new connection to the new master. That nasty, disgusting code example is going to walk you through exactly how you would update your route tables in your VPC to do this nasty, disgusting hack.
That's like a month's worth of work there, though. I mean,
Yes.
That's like really valuable.
Yes.
It pays for your whole trip here.
Mr. John.
So, master fails.
Yes.
And the MHA node is in available zone 2. Master goes to AZ2. Now they're on the same. What happens?
Yep. So the question was, MHA notices that you have a failed master, and it just happens to choose the new master as being in the same availability zone as itself. The answer is that's great, because it chose that slave to become the new master because it was the most up-to-date slave. And so it means that it has to replay less of the bin logs onto MySQL to catch it up to current state so that you lose the least data. Yeah, it sucks. You've got another problem on your hands to go fix when you're at work and in the office.
What happens if the MHA node goes away?
What happens if the MHA node goes away? The MHA node is in its auto-scaling group, and it itself is also managed by Chef. And so if Chef detects that it's not running, it'll get restarted when the next Chef run happens. So that captures process death. If the EC2 instance just goes south and dies, hopefully Amazon fully tears it down and takes it away so that they provision you a new one.
Is MHA triggering the change of the IP to ENI mapping in the route table?
It is MHA triggering the IP switching? And the answer is yes. And that's a combination of native capability of MHA and then MHA helper make here. And it's calling something that actually looks a lot like this. It does some more stuff, to be honest, to read slave VIPs to make it a little more robust. But
the MHA instance is actually talking to the Amazon API.
the MHA instance is indeed talking to the Amazon APIs. An interesting tidbit of information, we're using instance profiles for all of our instances in Amazon so that we don't have credentials floating around on all the boxes, so that MHA can talk to those CLIs without a problem. Cool. So the end result takes about 11 seconds when there's a detection of failure before the code and the applications are all ready and talking to the new master. Alan, one of the coworkers in Austin, is actually working on auto bootstrap of new slaves when they come back online, so that they'll go capture the latest backup, restore it locally, and then start slaving off of the master immediately. So that's going to be like an entirely hands-on management of our MySQL infrastructure. And now you can slow clap. Yeah, nice. So that was about a month and a half of work, and I'm sure somebody like Ovays could come in and do it in like 4 days and drink beer while he's doing it.
Right, it turns out it's
Yeah. Cool. So the next piece of tech is Elasticsearch. By and large, Elasticsearch compared to everything else is the easiest thing of everything we have to run in Amazon. We had a version of Elasticsearch used by our code that it just kind of worked. And when we didn't have very many customers, that version of Elasticsearch is just fine. But then when we started growing, fat guy in a little coat style, it started to fail on us and started to deadlock. And so we had to break out the IDE and do an update. And there's some challenges to that I'll talk on the next slide. But the idea is generally that we now write to 2 clusters every time we want to index something, but we only ever read from one of them. Okay, so that this allows us, one is now we have a hot standby for failover if one of the clusters locks up. We also have the ability to do online bulk reindexing if we ever change our Elasticsearch schemas. Okay. We use the AWS plugin and Elasticsearch in order to facilitate discovery, since you can't do multicast in EC2. Works out well. We use the tag-based discovery with that plugin. And the biggest tip I can really offer you with running Elasticsearch is to make sure that you tune the open file descriptors and make sure that you with the limits D and stuff like that. Otherwise, if you overrun that, the cluster will die. It will fail hard. Before where when that happens, the indices become corrupt and you can't restart and you have to re-index everything from scratch. With our amount of data, it would take weeks to do, and the application would be completely unusable while we're re-indexing. So, tune your file descriptors. A quick note on this, just because it might be beneficial. You spilled your drink. Might be beneficial. When we went from 19.10 to 1.3.2 of Elasticsearch, there was such a massive jump that the thrift client, or the native client that comes with Elasticsearch, can't talk to the old version and the new version. The APIs had differed so significantly that it just wouldn't work. And so we had to go with the Jest, which is a client from the guys at Searchbox, which uses the REST interfaces of Elasticsearch, and are therefore a lot more decoupled from the actual version of Elasticsearch that you're talking to. However, turns out that that version of Jest that can talk to 1.3.2 won't work on the old cluster either. So we had to maintain two separate code paths, but a fun trick is that if you build up a query with your native Elasticsearch client in your Java code, you can still build it up with a thrift client and two-string it and send it to Jest. Works like we sent these guys a pull request for reaping idle connections out of the HTTP client pool. They accepted it, merged it in, so hooray for open source. We also use Zookeeper. Zookeeper for leader election and a couple pieces of our puzzle. We also use it for service registry. So when you're spinning nodes up and down, what's the IP address? Who knows? I don't want to have ELBs running everywhere. So we use Zookeeper for that. We use Netflix's Exhibitor as a sidecar process or a co-process to Zookeeper. And it makes bootstrapping your Zookeeper ensemble a lot easier. It kind of just worked. I was shocked. We didn't have to modify it at all. Just read the docs, config it correctly, and you'll be off to the races. Just a tip on Zookeeper, don't store persistent data there. It's just not what it's designed for. When we first started using Zookeeper in our data center, everybody was like, yeah, this is cool. I don't have a need for it right now, but we might use it. And then when we talked about moving it into Amazon, people started crawling out of the woodworks saying that it doesn't work in Amazon, don't. But it does. And it does, especially if you put Zookeeper entirely on ephemeral SSD disk and not EBS, because it is very sensitive to disk I/O latency. And so by putting it on ephemeral local disk, you kind of sidestep a lot of those problems. And since you're not storing persistent data in it, you don't care if the node goes away. Cool? Redis. Okay. The next two technologies we're going to talk about are where we made some missteps. Redis as a technology, I love it. When we built automation to run our own Redis cluster in, and I say cluster in air quotes because those of you that use Redis know that it doesn't support clustering yet, and the version that does is still in beta. When we built this, Elasticache Redis did not have auto failover yet. It could run multi-availability zone, but if your master died, they would not fail over to one of your read slaves for you. And so that was kind of a buzzkill, because if that availability zone goes away, Amazon won't kind of shuffle things under the covers for you. So we embarked on this fun project, which I'll walk you through, but I don't recommend it. We're actually very actively talking about cutting loose everything that I'm just about to show you in order to use Elasticache Redis. We opted to use a Python sidecar or co-process with the Kazoo library to talk to Zookeeper to do leader election. So the idea is that your co-process right next to your Redis process will, if it becomes the leader, it will set the guy right next to it as the master. And then the other two nodes in your autoscale group will know that, hey, I'm not the leader for this cluster. Therefore, I'm going to become a slave of the guy that is the master. And I'm going to start taking backups and shipping my RDB files out to S3. The problem that we're having is that the sidecar process keeps disconnecting from Zookeeper and unnecessarily causing a lot of churn. The failover works. It's just that there's never any problem with Redis itself. It's solid. It's just that the watchdog process keeps dying, and it's just dumb churn. So don't recommend. Another black eye is our queuing system. This sucked. Because it was one of those things that I got really passionate about and went to all the other engineers in Austin. I was like, yeah, let's do this. This is going to be great. And then it totally failed. So I had to eat a little crow on that one. We currently use ActiveMQ 5.7 in our data center. ActiveMQ 5.10 added support for Zookeeper to facilitate standing up your own cluster of ActiveMQ nodes. Unfortunately, the box, ActiveMQ 5.10, doesn't even start. Like, you have to go and remove a jar from the class path in order for it to start, which I thought seemed kind of lame. It made me ask myself, do you guys actually test your shit? Because that's dumb. And even when you do work around that problem, which I had automated with Chef, it turned out that when you trigger a failover, it would go and replay every message that ever went through the broker, even the ones that have been acked and fully delivered, to the new master. It's like, that doesn't scale well, because even just in my local performance testing, I'd sling 50,000 messages at it, and it'd take 20 minutes to do a failover. That seemed kind of dumb. And so then I fire off email, hey guys, let's go and use RabbitMQ. That looks cool. Nobody in our office, or even here in San Francisco, I think, knows Erlang. Any of you guys ever seen an Erlang log? It's like in logs, and it's kind of wicked. The clustering worked great in QA stage in our performance testing, but I think it lasted 3.5 days in production when we put it out. So it's just fireworks. Split brain, lack of quorum. It seemed like if you put it under too much load, it just stopped communicating with other nodes in the cluster, and then it just gave up and threw itself into an inconsistent state. So that kind of sucked too. What's that? I want to say it was M3 2X large. I tried giving it more cores and more RAM, and it didn't work either. The question was, what instance size were we using for that? This was like Monday night. It lasted through the weekend. We launched it on a Friday. Good idea. It made it through to Monday at 11 o'clock, sitting at my kitchen table, and I was like, I don't know what to do. If this doesn't work, our customers don't get tweets. Our customers don't get Facebook data. And we have lovely, very verbose customers that pay us. Yes, and they pay us for the things that I won't be able to give them if I don't fix this. So I switched everything back to go over VPN links into the data center and grab a connection to ActiveMQ again, because we thought, hey, let's just leave it running for a second just to make sure that works. And yes, for those of you that are familiar with RabbitMQ, it has a very specific setting for what to do when it loses its mind in EC2. And we set it. And it still didn't work. And I love the tagline is messaging that just works. Oh, really? So long story short, we're on active path to using SQS. And we're just going to let Amazon do the dance with that. So our queuing needs are pretty simple. And yeah. And in reality, when you do the cost modeling, it's actually cheaper, way cheaper with our load to use SQS than it is to run your own cluster of RabbitMQ, ActiveMQ, ZeroMQ, whatever you want to use, brokers. I think it's like $1 for 1 million messages or something. So then we come to the actual Java apps themselves, the actual business apps. This was the easy part because you have like a whole office full of people that know about that application. And we all have been sleeping, and breathing that application and its config files for years. And so we kind of sailed right through this part. The app itself was already mostly scaling, meaning you could stamp out more copies of it and they would just do more work. The trickiest part of this was, okay, we've created all this auto-scaling, auto-failover for MySQL, Redis, Elasticsearch, queuing. How do you tell your application where all of that stuff is? And so we use a combination, like I mentioned earlier, of zookeeper to do discovery, as well as when the Chef client runs, it'll call Amazon CLIs and go find things based on tags. We come really close in a lot of cases to using the maximum number of tags in our instances. And so then that run, every time Chef Solo runs on the box, it's so that it runs every 15 minutes, it'll rerun that query and plop down the new IP addresses, host names, whatever it finds. Cool. One of the bigger concerns we had with moving to the public cloud was that it's public. It's not in our data center. And we had to do our due diligence to ensure that our customers' data is at least as safe as it is in our own data center. So we opted to use, and we didn't want there to be any location on an EC2 instance that was off limits to put things, because that's just asking for a developer to not know the rules and put something somewhere where it's not supposed to be. So we figured out a way to encrypt the local ephemeral storage. So your box comes and it's got 2 SSDs in it, or 1. This example code here will show you exactly how you can encrypt that and mount it, so that then your SSD storage, local SSD storage, is now encrypted, so that the next poor sap who gets that box after you has absolutely no chance. And yes, Amazon says that they do the security dance and wipe the bits and all that stuff, but or you could do it yourself and not ever have to worry about it, and never have to trust that they do it. The EBS storage, it's actually, it got really easy halfway through our project. Amazon said, hey, we've got encrypted EBS volumes. And I was like, yes, don't have to solve that problem too. One challenge, though, is that I would have loved to have attached encrypted EBS volumes in our CloudFormation templates. But at least as of earlier this year, the CloudFormation templates don't let you specify in the block device mappings that volume should be encrypted. Hopefully, they'll eventually change it. In the interim, you can use something similar to what's in the script, that the very first Chef client run or the bootstrap process of the user data, create an instance, tag it, attach it, mount it, and keep going. So putting it all together, I've thrown like 10 different types of technology at you guys. As you guys know, there's a certain amount of orchestration that you do, right? You create a CloudFormation stack. You have to take a couple more steps with your application itself, like electing the initial master for MySQL, for example. We started off with bash scripts, and then things kept sneaking into those bash scripts that shouldn't have been there. And then Paul started writing a bunch of Ruby scripts. I hate Ruby, sorry. And then I got passive aggressive and started writing some Python scripts. Alan joined our team and said, your Python sucks, let's try this Python. And he made something really cool, which I'll show you an example of in a minute. And so Python ended up winning out, and this makes me happy. These Python scripts do nothing but interact with the Amazon CLIs to launch stacks, update CloudFormation stacks, and also do some very lightweight orchestration using Fabric. Yes? EBS encryption volume is supported in the templates now as a parameter to a launch configuration because there was a difference. You could create a volume and specify it only if you specify it as a top-level citizen in your CloudFormation template.
When that's there, you let us know, though.
Yeah.
Wait.
My email address is at the bottom. Like, tell me. Fabric is a kind of a Python plugin that we use just to do some remote code execution. We use it for things like triggering heap dumps, thread dumps of our Java apps, doing restarts when that dance is necessary, and also to deploy hotfixes of our code. Okay. If you guys are Python fanatics and you like remote code execution, I know you do. You'll love it. Here's the end-to-end flow. This is where we put it all together. This gives me goosebumps because this is about 10 months of work with 5 boxes. So happy developer comes in, makes a change to chef recipe, to the actual application code, don't care. Either one. That code goes up into GitHub or your Git repo. Jenkins is watching it and going to kick off a build of whatever that artifact is when it notices a new Git hash, builds an RPM from it, and then chucks it into the inbox in S3. The Yum repo manager, that little bit of Python that I showed you was open sourced, that is watching that inbox, detects that there's now a new RPM, recompiles the metadata, pushes up the new RPM back into S3. Cool, transaction done. I've now pushed an update to an artifact into an internally accessible code repo that I can get not only from dev, QA, but also stage and prod too. Then the developer says, this is a bad example because he's going straight to production, hot swap to prod. He's going to use a Fabric command. So the fab thing, that first token there, is invoking a Fabric script. And then the first part of that, up to the first colon, is the name of the task in Fabric. And we've got one, it's not quite named like this, but let's say it's myjavaapp.slowroll, which means that it's going to go to each existing application, stop the instance, install an update. And so specifically, it uses Fabric, goes onto the box, disables the cron job that's running Chef Solo so that we don't have Chef run right in the middle of our upgrade. We do a yum clean all to make sure that the new thing that's in the S3 repo is now available. Then run Chef Solo, right, which has been updated with new RPM of what's on the box. And we re-enable cron, and your software is live, at least with what we have. This is kind of a cloud anti-pattern in a little way, just to be honest with you. Like, people updating versions of their code on a long-lived box is not really ideal. We could have just as easily updated the CloudFormation stack and then terminated the instance and have it come back with a new version. That works too with this setup. It's just that it takes longer, right? In order for us to get to that point, I'd really prefer that we pre-bake an AMI so that the instance startup is like instantaneous. Because there's a lot of, installing Java, install security patches, all that stuff takes time. And so trade-offs, right? You could do it either way. Question, yes? How come we didn't use Chef? What are we doing in Fabric that we couldn't do in Chef? I can't have Chef know that I want to deploy an update. And I'm going to feel my way around your question a little bit, and you tell me if I'm getting close. The developer is who knows what needs to go, right? And so we just need to box and tell it to update. Keep in mind, we also still don't have a Chef master. And so we don't have one Chef master to go to and do a push of any instructions to go and run a command. Am I getting close? Yeah. Other questions?
Wrap it up
Okay.
using skipping in, so
Yeah.
Careful.
Yeah. Just a couple more slides left. Just to wrap up on some of the other tools that we're using to kind of complete the vision of developers kind of running their own thing. We use Datadog for monitoring, and we combine that with PagerDuty. All the cool, fancy, colorful graphs are courtesy of Datadog. Sorry, I blanked out the scale of these things in case you're a competitor. And then we use PagerDuty to do the paging. And we use Sumo Logic for centralized log collection. We ship all of our logs off there so that if the box ever dies for some unknown reason, we have at least a chance of understanding what happened. And all of that is installed and configured by Chef itself. I made it. An hour. 40 seconds.
Done. Well done.
Questions? Any questions? No? The Python, is it using Bodo? Yes. It'd be great if our Python wrappers were consistent. Some cases we're using Bodo. To actually launch the stack and update the stack, we're using Bodo. But for some other things, we're sub-processing out to use the AWS CLI. Yes, sir.
From commit to deploy, which part is the slowest or takes the longest or makes the biggest gap?
From commit to deploy, what is the slowest part or the biggest gap? The deploy is the longest part because if you're going to, and I say that primarily in the slow roll situation because you want the ELBs to notice that the software is back up and running, and you have to wait for those time windows to expire so that you don't rapid run through all of your boxes and tear them down and update them, and then suddenly realize that you've left the ELB healthy nodes underneath it. But yeah, this process, if we're not talking about our build and compile that takes an hour to run, which is not a problem of this process, it's a problem of our code. Things coming from Jenkins and being available in the S3 repos when that triggers and happens and is quiesced.
Connectivity from AWS to your Polos
Yep.
data center, what kind of are you using direct connect or
The connectivity from our colos to the VPCs that we have in Amazon. We actually run in many regions, and the regions that support it with our data center, we use Direct Connect. And for everything else, we're using VPN links. Other questions?
Is this where you want to be?
Is this where I want to be?
Is this,
What's
what's the future?
the future? This feels like a leading question. Yeah. So, yeah. Well, I've actually handed this project off to John. Who's over here. So, I'm going to let him make that decision on what's next. Did you hear the bus? Yeah. But no, I have no regrets about anything that we built here. But there's obviously room for improvements, right? Like, we made some missteps, we're going to correct those. But there's no part of this that I absolutely wish we could redo in a drastically different fashion. Other questions? No? Cool. Thanks for listening and not falling asleep.
Thanks, Matt. Really appreciate it. I want to thank everybody for coming out tonight, and would love to hear feedback. Let us know if like this type of content is really meaningful and helpful. I know for myself, I'm like looking for a little bit more intermediate to advanced type topics. So if you got ideas that you'd also like to submit, please send us an email. Let us know. And then once again, thanks, Matt, for coming out for Austin. And if you want to work with like guys who are going to push the limits of, believe me, I'm coming from an ops side, and this guy pushed the limits of what I know. So come join us at Lithium.